All right, prepping for the quiz today. Figured we'd do just kind of a couple main questions, stuff from a little earlier, back in like 6-1, just to make sure you remember it all. So it says population of bullfrogs loses 11% each year. If the initial population was 347 frogs, do the following. First thing, write the function, write the equation. All right, so remember A is the start value, so that's going to be the 347. So they started with 347 frogs. B is the rate, which the key to this is you have to add or subtract your rate to 1 to show growth or decay. Since they're losing, we're going to subtract. So we're going to do 1 minus, and then make sure you write this as a decimal, 0.11. So 1 minus 0.11 is going to be our rate. 1 minus 0.11 is 0.89. And so that's the value that we have to make sure we put in there for our B. That seems to be the place where most people have trouble. So again, just to recap it real quick, it's always 1 plus or minus your rate as a decimal. So if this said they were gaining 11%, this would simply be a plus, and it'd be 1.11. All right? But again, make sure you convert this to a decimal, and then add or subtract it to 1, depending on whether it's growth or decay. Which perfectly answers the next question. They're losing population. This is very obviously decay. You also would know that if you just looked at the equation. Anytime this number is below 1, it's decay. Anytime this number is above 1, it's growth. So it's very simple to identify growth or decay from the equation. Lastly, when does it reach 100 bullfrogs? For that, I like to use my table. You could sit there and just like do guess and check too, but table is definitely a little more efficient. So we get it entered in. We jump to our table, and so at 0, we can see there's our initial population. 1 year in, 2 year in, and so on. So we're looking for the first time it hits 100. So in this case, basically between years 10 and 11. So we'd say about 10 to 11 years. So sometime in between 10 and 11 is when it hits 100. Eventually, I think I've said this a few times, but eventually we're going to learn how to exactly solve for this. So you could say, hey, it was 10.32 years, but we don't have that skill yet. That actually comes in the next section we'll learn after this quiz. So as of right now, we're just kind of estimating, saying it's about somewhere in between here and here based off our table. All right, so that one's good. Next one says, for this equation, describe the transformation compared to the parent function 2 to the x. So these are both 2 to the x. The difference is this has a bunch of different things being done to it. And we've seen this all year, and it has never changed. So this should be easy peasy. So whatever you're multiplying out front, that is going to cause a stretch or a compression. In this case, it's less than 1. So it's a compression of 1/2. You could also mention that the y-intercept is going to be moved. But again, the really key here is when we're talking transformations, we're talking how is this graph getting moved or changed from this one. So compression of 1/2 is really the best way to say that. Anything that affects the x directly shifts it left or right. So in this case, this is going to be left 3. And this anything after, at the end of the function, or at the start, but usually at the end, is going to shift it up or down. In this case, it's going to go down 5. So that's what we would expect. The beauty of this is you can graph these and take a look at them and just make sure that you agree with it. So 2 to the x, the parent function, is our doubling function. This was like the very first one we learned when we learned about exponential functions. Looks like this. When we put all this other stuff to it, so we got the 1/2 times 2 to the x plus 3 has to be in parentheses, and then the minus 5 at the end. So we can look and see if it's doing all these things. So it definitely looks like it's shifted down 5. The left 3 is a little tougher to see, but you can see they're not like stacked right on top of each other, so it is definitely shifted to the left. And then as far as the compression, this initial one is steeper. This jumps up quicker. This one is a little more gradual. That's just a visual type of thing to see that it's a compression versus a stretch. If it was a stretch and this was a number like, let's say this was like a 5 out front here, it's going to make it considerably steeper. So if we look at this just as a comparison, see this one's going to shoot up quicker than the previous one did. And so that's really it. Yeah, hopefully, like I said, this stuff we've been doing for pretty much every section we've ever learned. So you hopefully feel pretty confident with that.